Welcome in. Let's open the terminal and start Module 4. Lesson 1, Routing Basics. Over the next few minutes, we're going to unpack what a router actually does when a packet shows up at its door and how it decides where that packet goes next. The core idea we'll keep coming back to is simple. A router's job is to pick the best path to a destination network and forward the packet along. Everything else builds on that. So, before we go deeper into routing, let's draw a clean line between two devices that often get confused. A switch operates at layer 2. It moves frames between devices inside the same network using MAC addresses. A router lives one layer up, at layer 3, moving packets between different networks using IP addresses. Put simply, the moment a packet needs to leave its own subnet, a switch can't help you anymore. You need a router to make that jump. And how does a router actually make that jump? It consults its routing table. Think of it as the router's brain, a running list of every network it knows about and the best way to reach each one. Look at the output from show IP route here. Each line tells you three things. How the route was learned, shown by that letter code on the left, the destination network itself, and either the next hop IP or the exit interface. So C means directly connected. R1 already sits on that network. S is a static route, someone manually configured, and O was learned dynamically through OSPF. Same table, three different sources of knowledge. Let's zoom in on those three sources. Connected routes are free. The moment you assign an IP to an interface and bring it up with no shutdown, the router knows that network exists. Static routes are the ones you type in by hand, which gives you total control but doesn't scale. And dynamic routes come from protocols like OSPF or EIGRP, where routers talk to each other and share what they've learned automatically. Three very different ways of populating that same routing table. So now the table is populated. But what happens when a packet actually arrives and there's more than one possible match? The router runs through three tiebreakers, always in this order. First, longest prefix match. A route to 10.1.1 or 24 beats a route to 10.0 or 8 because it's more specific. If two routes have the same prefix length, then administrative distance decides. The more trusted source wins. And only if those also tie does the metric, the actual cost, break the deadlock. And that's the foundation. How a router learns about networks, how it ranks them, and how it picks the winner when paths overlap. Next up, we'll roll up our sleeves and actually configure static routes ourselves, telling the router exactly where to send traffic line by line. If this lesson clicked for you, hit subscribe and turn on notifications so you don't miss lesson 2. See you in the next one.